to start the session, although I think we still have a number of people who aren't here yet, so we're going to allow a few more minutes before we get started properly.
Hey, Tim, can you say something so we can be sure the audio works?
Yeah, can you hear me? Nothing going on just yet, except.
Thank you.
No problem. We're just allowing a little more time for more participants to roll in, and then we'll get started in a couple more minutes. Okay, that's 5 past the hour, so I think we can sort of formally get started here. So this is the third, I think, interim MIMI session. Thanks all for joining. That's odd. There we go. So as usual, please note well the IETF note well and all the policies. And then let's get into today's agenda. So the only thing formally on the agenda is that Travis is going to spend some time explaining linearized matrix to us, and we'll have some questions after that. And then after that, nothing else formally on the agenda. So anything anybody wants to discuss can be brought up. Does anybody have any objections to the agenda or anything they'd like to add at this time? Okay, looks like we're all happy with the agenda. Last thing before we dive into Travis's deck is that we do need a volunteer to take notes on today's session. So please speak up if you're willing to do that. If we don't have anybody, I guess I'll just do it. All right. I think we can just move on into the first deck. Travis, are you ready?
Yeah.
I'm sorry, can you please repeat that?
Should be, yes.
Okay. Would you like me to drive the slides for you, or I think you can press a button to request control?
I'll probably just get you to do it. It's probably easier than trying to fight things.
Sure thing. There you go.
All
Just
right.
let me know when you'd like to change slides. Forgive me if there's a delay, because it looks like I'll also be taking notes while I do this. Go ahead.
No worries. Thanks. But yeah, so there was a updated draft for linearized matrix. I probably should have put that on the actual title card here, but oh well. But there is an 01 draft. It removes all the dependents off of spec.matrix.org. And these slides are kind of split into two parts. The first part being what linearized matrix is, just as a sort of recap for people who might not have seen the draft. And then the other half being a question around channel state and whether it should be client side or server side. But yeah, if I can get the next slide, please. Yeah, so the rough architecture is there is a hub server and multiple participant servers. This has been discussed multiple times already across the different sort of transport drafts, where yeah, the hub server is responsible for basically keeping track of the conversation, and the participant servers kind of just hold users and proxy everything to the hub server. Linearized matrix rooms are what hold events, events meaning pretty much anything to do with the room itself. So that could be a text message, it could be an image, it could be a membership change, it could be the room name changing itself, that sort of stuff. We call events over the wire PDUs or persistent data units. It's just a slight distinction there. Next slide, please. Yep, all the behavior for a room is defined by the room version. More on that in a second. Users are what send events. They can have 0 or more devices. Devices are effectively what MLS would call a key or a device in the group. Room versions are somewhat complicated in Matrix, and honestly, they're just not well named. The rough idea is that all of the ACLs, all of the behaviors, algorithms, all that sort of stuff that actually runs the room is defined by a single room version, and a room version is identified by a string. With that room version, you end up with everything you need for how power levels work, how messages are accepted or events are accepted. All that stuff is defined by the room version, but it doesn't necessarily need to be server side. It can be run on either area. They are frozen once defined. Rohan?
Yeah, I found this terminology a little bit confusing when I was reading it. Would you? I feel like I understand it now, but would you feel like it'd be a good characterization that this is like that this is basically a capabilities negotiation? That the room version is just like as you add new capabilities, you create a new version string, and people can coalesce on a specific set of capabilities that are associated with that quote unquote room version string.
Yeah, it would probably be best categorized as that. Yeah, because yeah, like they're frozen once defined by a spec process of some kind. So like it's not like you can just change how rooms work. And so yeah, everybody needs to support that version. You would also know well in advance whether or not you can even join that room, because the room version would be told to you as a server or as a client, depending on where we put it. So like you wouldn't be able to actually join or anything like that. Alyssa?
Yeah, I'm just wondering about there being like a baseline version that everybody supports. Because I think that like what you just spoke about, this like finding out that there's a room that you can't join for the sake of interop, is there a value in having like the simple version, and this is the thing that every implementation would be supporting, and then you can like do other things on top of this that are more complicated, and find out that you don't support what somebody else supports. But is that notion present, or should it be for MIMI purposes?
Yeah, so the intended purpose of linearized matrix, at least in the draft, is to actually specify sort of like the first room version. I think it calls it like I.1 for no particular reason. But yeah, like it would have all of the semantics, all the behaviors, so that way everybody at least has something to go off of. In practice, you can define sort of custom room versions, but the reality is nobody actually does that outside of sort of specifying it through an additional document.
Okay, that's good.
So
Yeah, I feel like we like simplify for this. So.
Could I just read that back to confirm, Travis? It sounds like you're saying that like at least the first iteration of linearized matrix would define a specific new room version that captures the linearized matrix capabilities that would kind of be the target for MIMI. Is that about right?
Yeah, so there would be an initial room version. That room version has all of it, or all of the behaviors that like I'm about to kind of go into, and that sort of stuff. It would all be in the same room version. If we ever needed to make a change to it, it would just be a document saying, or a new ID saying, hey, yeah, we want to specify I.2 or I.3 or whatever. And then we can just kind of build off of it from there. I'm assuming that's starting to make some amount of sense. I'll take silence as yes.
Yeah, the mute button here takes 5 seconds, so silence is yes. Thanks.
Yeah, sorry. Also, so because Tim is running the slides, I'm taking notes. So sorry, I didn't come back and unmute.
Yep, no worries. Yeah, so each room version is frozen. Technically, the room versions aren't linear, so I.2 does not necessarily have to follow I.1 or inherit from I.1 in any sort of way. And the reason why we call them room versions is because a room can sort of upgrade between these things, which is, again, just like a really awful term when they're not linear, because it is technically possible to go from I.2 to I.1 if you wanted those characteristics instead. In practice, what upgrading really means is you create a new room with that room version, and then add a bunch of stuff to the room so that way clients know to either splice or link or whatever to deal with the two separate rooms visually. But at a sort of protocol level, they are two entirely different rooms, which would mean two entirely different MLS groups. Yeah. Next slide, please. So yeah, this will be the same diagram that people have seen before in many different shapes, just as a slightly different shape. You have a central provider. Provider A, in this case, is the hub. Provider B, the gatekeepers, and the existing DAG-capable matrix are all participant servers in this example. The green things are clients or devices, depending on how you want to look at it. If you're familiar with matrix as it currently exists outside of linearized matrix, it does run off of a DAG. That's represented here as it just magically works. We're just not going to necessarily get into the details in these sorts of interms, at least for the moment. Gatekeepers, since they're a much larger sort of organization, they might have a slightly weird internal structure, but the idea is that there is a sort of public-facing linearized matrix server that is capable of speaking this protocol. Richard?
Yeah, so Travis, when you and I talked about this before, kind of out of band, one of the bits of complexity that bled over from full fat matrix into linearized matrix was that despite the sequence of events in linearized matrix being linear, it wasn't append only. Because if there are events in some chunk of the DAG in the full fat universe, that right-hand bubble, that could cause rewriting in the history of the linearized version. Is that still the case in the current version?
Linearized matrix in the current version does fix that. So it's no longer affected by what might be going on the sort of decentralized or federated side of things. It just is append only. It magically works. That sort of stuff.
Okay, so the view that provider B gets here as a follower of the hub of provider A, the view that provider B gets would be a linear append only history.
Yes.
Okay, cool, great, thanks. That's a great improvement.
Yep. Next slide, please. Everything in matrix and linearized matrix is sent as an event. There are two kinds of events: state events and room events. But yeah, the rough idea for a state event is that it tracks sort of metadata for the room, user membership, name, join rules, power levels, that sort of stuff. They are keyed by an event type and state key tuple, and they overwrite each other, where current state is just the most recent one that was sent, as defined by the append only log sort of idea. We don't use a dedicated event ID. The event ID is just the reference hash of the event itself. This protects against basically malicious actors. Primarily, if you use a UUID or a namespace or something to that effect, the easiest consideration is that other people can create collisions fairly trivially. Although the downside of obviously using a reference hash is that you are tied to a hashing algorithm of some kind, usually some sort of SHA-256 or something, which also can obviously have collisions as well. That would be fixed in a sort of proactive room version change. So before we necessarily encounter that sort of problem, as it sort of starts to be a looming problem of some kind, there would be yet another room version being sort of cut and put into the works there. Conrad? If you're speaking, I can't hear you.
Okay, now?
Yep.
Right. Sorry. So maybe I'm jumping ahead a bit, but and maybe we talk about this later. So if we will, then please just interrupt me. Does this mean that events are broadcast to all servers? So, for example, changes in room membership, or that room membership, for example, generally is tracked by all participating servers or hubs?
Yeah. So the hub server is the only one that's actually required to actually keep track of current state and all that stuff. The participants can if they want to, but there's no necessity for it. The idea is that, yeah, you can, or all of these are broadcast anyways, because they have to end up on clients in some capacity. So you know, just as a user, that somebody joined the room or left the room or whatever. But the participant servers can just act as basically store and forward nodes if they really wanted to.
But is it required that they're transmitted in the clear? So they could be transmitted encrypted from the hub, the original hub, to the clients?
Yeah, I think that'll be more in the channel state discussion, the sort of latter half of this deck, where we start talking about whether or not this information needs to be client side, meaning within the MLS group, or server side, where it currently resides, where it is in the clear.
All right, thank you.
Yep. But yeah, room events are basically everything else that isn't a state event. So that would be your text messages, your image events, that sort of stuff. Next slide, please. Yeah, so just so that we're kind of all on the sort of same page, because like a lot of this stuff was discussed 2 interms ago, and there was some, I guess, disagreement around ACLs. And what that might have actually meant. So for the purposes of this sort of deck, the ACLs are what the room version defines. So everybody knows what is required of it. There's not necessarily a need for a domain-specific language. As long as you support that room version, like I.1 or whichever, you will be fine. And again, you'll know well in advance as a server, or I guess as a client, whether or not you're actually capable of participating in that room. Because yeah, like you'll have all of these room versions negotiated and that sort of stuff. Does that make sense so far, Conrad? I think you're still in the queue, or rejoin the queue. All right, Richard.
Yes. So sorry if I missed something here. Like, it's unclear to me how these power levels map to like actual, rules about who can do what. Is that defined as part of the room version?
Yeah. So the auth rules basically define what is like upon receipt of an event. What are the conditions required to accept it? Power levels is how matrix maps permissions and roles and that sort of stuff. So power levels is a relatively large state event that has basically a string key to a integer value. And basically the higher the integer, the more power level you have. Users are also defined to have a particular power level. Roughly speaking, 100 is usually an admin, 50 is usually a moderator, and then everybody else is 0, but you can also go anywhere within the int32 maximum range if you really wanted to. So like the rough idea is that like to ban, you need a power level of 50, which means anybody who has 50 or greater can ban, that sort of stuff.
Right. So I think what I'm asking is, where do those sort of rules get encoded? Like that map you just said, where you need a power level of 50 to be able to ban. Like where does that live? Is that a fixed property of the room version, or is that written down somewhere and I download that at short time?
So it's in 2 places, I guess. So the actual sort of definition of what requires what level, that is defined in the power level state event. So that is embedded into the room as part of just the normal room state. The actual enforcement of those power levels is defined by the auth rules, which are part of the room version. So everybody knows how to interpret those rules as part of just being a member of the room.
Okay, so it sounds like there's a broad framework that is established as part of the room version, but then the specific mapping of the integers to those rules is set as part of the room setup. Right?
Yeah. So there's like ban, kick, invite, redact. Like what level do you what number do you need to have in order to be able to do these particular actions?
Okay, so the right, and so you're saying that those thresholds are set in the room setup.
Yeah, and they're changeable throughout, which is why they're part of the sort of room state. So like after the room's created, you can. Sorry, go ahead.
So it seems like the presumption here is that there's like a total ordering on roles, basically, that any two roles you have, one will be more powerful than the other. And will have all the capabilities of the lower level.
We've been using that sort of system for years now, and it bridges fine to everything, save for maybe Discord. Discord's role-based access control is different, but there's also like we can just swap that out in a room version if we wanted to.
Okay, all right. Thank you for the clarification.
Yeah, Eric.
I'm still a little puzzled. So let me try to restate what I thought I heard, and maybe you can tell me if I'm wrong, and if so, why. That the specific set of activities that one is able to do is defined by the room version, but the levels that are required to do those roles is defined by some configuration.
Roughly, yes. I'll reiterate it just as a sort of different way. So yeah, like the actual configuration of like what requires what, that's just part of the room, and then the actual enforcement is defined by the room version.
I don't understand what actual enforcement is defined by means. That's the problem. I have a problem with.
Yeah, so like when you send a new event, like let's say you are trying to ban somebody, that requires sending an event. The actual ban event gets sent over the wire, gets received by a server somewhere. That could be the hub server, it could be a participant server that's going above and beyond. And so once it receives that event, it goes, yes, this looks like a ban. It'll run it through the authorization rules, which actually define, like, in addition to all of this stuff, but also how to detect that it is a ban, for instance, because you'll be sending an mroom member event with a membership of ban. And so it falls into a case of like, it's basically a giant if else ladder. So it'll fall through into that, and then it'll tell you how to process that. Where it's like, okay, in order for this event to be allowed, the sender needs to have this certain power level. If they don't, just reject the event, and then nobody ever sees it.
Yeah, but now confuse the power level again. Power level specified in the room version, in the room configuration, right?
Yep. So it tells you to look up the current user's power level, and there's a definition of how to actually interpret that power level state event.
I'm sorry, I'm still confused. The user's power level is part of the room state, but is the power level required to do an action part of the room state?
Could you rephrase that?
Does the RFC say to ban you have to have 50, or does it say to ban you have to have the thing specified in some configuration document associated with the room?
The latter.
The latter.
Great, thank you.
Yeah. With all the ACLs, they're all defined as part of the room version. The ID goes into detail about like what the actual currently proposed rules are, and also like what the mroom power levels event looks like, if you're kind of curious there. It is called the auth rules algorithm, 542 in the document. So next slide, please. Right. So channel state is the sort of term taken by Eric's slides, number 14, if you're interested, back about a month ago. So traditionally, Matrix and linearized Matrix handles this sort of channel state server side. We call it room state. And then we would try and keep the MLS group in sync through rules defined on the clients. But MLS is also capable of handling nearly all of this client side if it wants to. And obviously linearized matrix can support either. So I'm just going to jump through a couple of the slides, and then we'll kind of just open up the floor to just like the sort of wider question here. But if I can get the next slide, please, where we talk about the server side stuff. So in this model, MLS only handles the device key membership in a group, but it's informed on what's going on sort of in the room. So which users are joining, whichever rules we end up creating for basically making sure that Alice's 0 or more devices are actually participating in that group appropriately. That is undefined at the moment. That will need to be figured out if we decide on this sort of model. But the servers end up rejecting the events based off of permissions, power levels, or just general structure. If it's a malformed event, it should obviously be rejected. But there is the obvious security flaw of without cross-signing or some sort of device verification structure, a server can maliciously involve a device in the MLS group by simply just appending it to a user, for instance, and that causing the instruction to add that device to the group. We would solve this by somehow defining some sort of rule that prevents that. Conrad. No audio once again.
Sorry, my Linux keeps picking the wrong audio device. So do I understand this correctly? So the server would then kind of make a client add someone to the group on the MLS level?
Within reason, yeah. Like there would be some sort of semantics that would say like, hey, when you see Alice create a new device, they would be somehow involved in the MLS group, whether that's an external join or something similar to that. Same thing for like when Alice loses a device. That would have to be resolved somehow. And so like that's where the sort of servers being able to inject devices into the group becomes a bit of a problem.
Okay, but then, sorry, then I have a follow-up question. It's not clear to me what you mean by cross-signing. I mean, because of MLS, every client knows like who is in the group, right? So the server can, in theory, inject, like quote unquote, inject a malicious device into the group, but all clients will know at all times to which devices they will encrypt, and they will know that all other clients know as well, right? So if the server were to inject a new device for any user, that user would notice at least as soon as it would come online, right?
Yeah, the problem is that like damage is already done once the device is in the room or in the group. Like if you're already encrypting for that device, then like no amount of prompt or anything like that is going to prevent that device from receiving traffic.
I see.
Cross-signing in this case is basically saying just like, hey, I created a new device and I can cryptographically prove that it is actually my device and not just the server logging in as me, for instance, because it has access to be able to do that.
Right, I see. Okay, thanks.
Eric?
There are at least 3 different scenarios here. I think the easiest scenario is the one of adding a new device for an existing user that's in the room. And in that scenario, I mean, we assume we have some authentication structure that authenticates endpoints and or people, and when someone adds a new device, that device should be authenticated via that authentication structure. And so I'm being vague about this, but like, if hypothetically it's like, certificates plus KT, then the server should not be able to mount this attack because they can't authenticate as the user. So I don't think that needs cross-signing. That needs ordinary authentication. The more difficult problems are the ones about manipulating the conceptual membership of the group in terms of users rather than devices. And so in terms of the addition of a new member, as Conrad says, it is true that the membership of the group is manifest to all users, but that doesn't mean that that in a substantial size group that the group member that the group members know who ought to be in the group. So I think we probably, as we discussed previously, we probably do need some way for to have groups that have the policy that only members can add people, but we also need some way to have the policy that that the server can add people, and I think that, but and the former, of course, need access control in terms of what you're calling cross-signing, but I would just call signing, which is to say signing the manifest of users who are allowed to be in the group. I think under the circumstances, once that's finished, I think the answer is external join rather than having some group member do a join, because who knows who group member will be online. The hardest part, however, is kicking, which the server can't do because it's not part of the group. And so someone will have to, what the server can do is change the room roster. But what it can't do is actually evict someone from the MLS group. And so that requires someone in the MLS group to do the eviction. As I understand MLS.
That's not true. You can do an external proposal. The server can do an external proposal, and that's.
But it's not to be accepted by somebody.
Yeah, it has to be accepted. It has to be in the.
There's a mechanism for folks outside of the group sending proposals, but what the server can't do is commit that proposal. So you'd have to have some mechanism by which the server publishes the proposal, and then whoever next comes online commits it. So the server can sort of kick, but can't actually put it into effect.
Right.
Yeah, I guess the server could instruct that, hey, this person or this device rather needs to be removed from the MLS group, and then it's on the existing members to make that actual call.
Right, but
and the server could even enforce a policy, like the server knows who's online. The server can enforce a policy that it's not going to accept any events until its proposal is committed.
Potentially, yeah. Yeah, that would fall definitely into the sort of like rules of engagement here, I think.
So I think that the new technical mechanism that's actually required here is the mechanism. It seems to me that the logic that the MLS implementation on existing group participants has to be is when a new person, there needs to be like the concept of a room roster. And when a new person has to join the group, they examine the identity, compare it against a roster. If that's permitted, then you accept the external join. If you don't, you don't. And so the new mechanism, and so I'm sure Matrix has that concept. The new mechanism required here is the ability for users in the room to sign the roster, thus allowing you to create groups which only participants can manipulate.
Conrad? I think you're on the wrong audio device again.
Yeah, sorry, I'll have to do that manually. I'll figure it out in between. Anyway, so since we're discussing membership and MLS is essentially already tracking membership, this kind of leads me to another question. Are you considering MLS messages in like public messages or private messages? So like encrypted MLS messages or plain text, like handshake messages at least?
What do you mean by that? Sorry, the crypto side specifically is like less of my sort of wheelhouse,
okay.
But like,
sorry, maybe let me explain real quick. So in MLS, you can messages, and especially handshake messages, can either be sent encrypted or unencrypted. And if it's unencrypted, it obviously leaks everything that's inside the message, but that's not necessarily kind of user sent data. That's more concerning the group state. So that would be adding, removing, and these kind of things, handshake data. And you can send them encrypted so that it leaks to the servers. I think the group ID, the content of the message, or if it's the content type of the message. So if it's a proposal or a commit, and the current epoch or something. And so I guess what I'm trying to say is that a server can easily kind of just track the MLS membership if we use plain text handshake messages. So public handshake messages. And then the server can also check if it wants to kick a member. It can also check if the next message is a commit, if it doesn't indeed include the remove proposal it previously kind of enforced on the group. So yeah. So just as a if you haven't really looked into that in terms of how linearized matrix can interact with MLS, that's certainly a thing I will take a look at.
Yeah, I've been told by the crypto team that, or in the past, that we would encrypt it as much as we possibly can. If we sort of make it, like, it depends on where, I guess, like, we fall on those sorts of rules for adding or removing devices from the MLS group. If we require that the server, needs to see that the proposal is accepted, then yeah, we would probably need it to be plain text. But if we can come up with something, I guess, reliable, where the server doesn't need to see that information and doesn't really care about that information, then we should definitely encrypt it. And then depending on like where we fall in between those 2 points would, I guess, depend on sort of which specifics are encrypted and which specifics aren't. Richard?
Yeah, I was going to say, as a general rule, I would propose that we kind of adopt the goal of using encrypted MLS messages everywhere, or at least being compatible with that option. Now, it may be that certain things are not compatible with that, and so the way I would propose that we proceed as a working group is to start out from the assumption that the server can't see inside any MLS messages that is sent, including the proposals and commits that manipulate the MLS state. And then only if there's some critical feature we can't do we create cases where you would need to send unencrypted messages.
Yeah. Conrad?
Okay. So Richard, can you maybe elaborate on why you think we should do this? So, sorry, and I want to kind of motivate this question before you respond, because we try to look at both. And when we started out with encrypted handshake messages, obviously with the idea of protecting as much as possible from the eyes of the server, we afterwards noticed ourselves kind of building all the stuff that we wanted to have on the server, kind of building it outside of MLS again. And you have a notion of you have a notion of members, and the members somehow have to authenticate to the server that they're part of the group, et cetera, et cetera. And so in the end, what we ended up doing in our delivery service proposal is decided on just doing plaintext messages and kind of obfuscating the metadata by using pseudonyms and that kind of stuff. So yeah, I'd be curious to hear why you think this should be required.
I was not trying to articulate a requirement as much as an aspiration. So I think we should, well, if I come to this as you might imagine a naive reader would say, we should be using the strongest security settings everywhere, and justifying when we don't use the strongest. So I think mainly what I'm saying is, if we decide to go to adopt a position that MLS messages need not be encrypted, or must not be encrypted, it might be a possibility. We just need a section on security considerations that elaborates why. Basically the stuff you just said, Connor.
Sure. I mean, we can see and go ahead how far we get. One thing that we noticed is what we very likely want on the server is some as much kind of as in terms of message verification as possible, because especially in a federated environment, you otherwise really quickly get messages that fork a group or otherwise send garbage, make the server increment the epoch, and then you have to roll it back, etc. So that kind of stuff, you can mitigate a lot of these the potential for malformed messages by sending plaintext handshake messages and then have the server verify a lot of the properties that you want.
Yeah, and I'm sympathetic that a lot of what you're protecting in those handshake messages is the roster of the group, which the server putatively already knows anyway. I'm a little wary, though, when it comes to the possible extensions you might use in MLS that might have stuff you don't want to be accessible to the server. Though it's possible you could design some protected extension model that You could have plain
Yeah.
text on the outside, but encryption stuff inside.
Yeah, we're already kind of in the process of drafting like an encrypted extension, I guess. So yeah, sorry, Travis.
Yep, no worries. On the matrix side, we also have something called DMLS, or decentralized MLS, which theoretically could be applied to both the server side and client side model in this deck here. The rough idea is that basically your epochs become a small DAG associated with each device, and then you run a conflict resolution on them. And so it allows you to have those divergences in MLS state and group and that sort of stuff without having to make the server aware of it. So you would still be able to encrypt a lot of that stuff. But that's not necessarily described in the draft at the moment. I think it's referenced, but not actually written down. But yeah, I think that adequately covers the server side for now. Once, twice, three times. All right, next slide, please. Client slide is pretty much the complete opposite of this. So servers pretty much just check to make sure that the actual syntax of an event is okay, or as much as of it that it can see, because like these would be all encrypted payloads. Everything is run within MLS. The act of accepting, rejecting events, adding, removing users, which would probably change the membership model to be per device rather than per user. All that stuff, the server doesn't see any of that. It just receives an event, goes, yes, that looks like an appropriately formed whatever, and sends it off to its local clients. Or in the case of the hub server, it sends it off all to the participant servers as well. The obvious downside for this one is the client complexity goes way up. You need a ton of conflict resolution. There's also a bunch of data waste, where the clients know that things were accepted or rejected, but the server doesn't necessarily know, because it can't form basically that linearized. It can't form what the room actually looks like because it just doesn't know, and it can't necessarily trust a random client on its, or as part of the sort of membership, to just say that this was accepted, because there could be another device that says that it doesn't, and then you have that sort of problem going on there. So ultimately, you just let it happen within MLS. Everybody knows, again, with the MLS group, that we are using this room version, which means we're using these ACLs, which means you can accept and reject different proposals and commits that way. Richard?
Yeah, sorry, I just have a little bit of a meta question here, in that I may have missed, like, why are we talking about server side versus client side room models? Like my impression was that Matrix, the way it runs today, is basically all the state is maintained on servers, and clients have a very simplified state machine. So are you proposing kind of departing from that model and building a new model where more state is kept client side, which I guess would mean that the participant servers would just be routers?
So this is falling back to, like the conversation at a couple interms ago, where pretty much the question of just like, should it be server side or client side, was raised, but there didn't seem to be an answer. So linearized matrix can do either, and so this is realistically the sort of question of which do we want to do as a working group, which is clarified on the sort of next slide, but like covering like the server side and client side individual pieces is important, I think.
Yeah. So I wanted to comment on one thing in your slide. It said servers don't know what was accepted or rejected. So that's only true if the commits are private message. If the commits are private message, then it seems unlikely that that we would be able to do external joins, which it sounds like from previous discussions that we're going to require. So I don't know anybody who is doing a serious implementation of MLS that's using, for messaging, that's using, or that, that needs this kind of property where you can do an external commit that is doing, encrypted MLS commits.
Yeah, there are definitely aspects that MLS can't necessarily handle. The client-side server room model does aim to use private messages as much as possible, if not exclusively, where it can. But there are obviously the sort of edge cases of eventually you're going to need to kick a device. You will need to add a device, that sort of stuff. But the rough theory is
kicking a device you can do without, but basically, if you want devices to be able to go and add themselves, I think that you're going to find that all of your commits need to be public message.
Yeah, and like that might be a disadvantage of basically using a client-side room model. Much like with a server-side room model, there are an equal number of disadvantages, which is largely why this conversation is being brought up. Richard?
I think anything we do in MIMI is going to require using public message for commits. And I think among the people who've been actively working on MLS, I think that that's actually non-controversial.
Yeah, I want to second Rohan on this. I also think we want to do public message. It lands you essentially a bit between the server and the client-side room model, where you get the advantages of both essentially. So the server can do all the checks and do tracking, and can support external joins, can keep the, can assist clients joining by having them download because it tracks the registry essentially, like allowing clients to avoid uploading the whole group state again and again. And so, yeah, so at least to me, there seem to be a lot of advantages. And as far as we have seen, the disadvantages can be mitigated to a large degree. But again, we'll see what the requirements are that we run into. But yeah, I second Rohan generally here.
Richard?
Yeah, I just wanted to be clear that I was, in my earlier comments, I did not mean to be dogmatic about, about requiring private message. In the product I ship, we use public message as well, just like Ron suggested. So I think it's very plausible and up there. I think it's just useful to keep an eye on when we might be able to use private message and keep track of why we're using public message.
Yeah, I mean, like my personal belief is that wherever we can, we should be encrypting this sort of stuff. But if there's a necessity to make it public, obviously that starts to apply. Alyssa?
So can we sort of put the client-side room model to bed then? Like, do we need to continue to evaluate it?
That's kind of what I'm hearing. If we can go to the next slide, it kind of raises this question of just like, which one should we go with? And also, does it need to be cryptographically bound? What I'm currently hearing is that, yeah, like we would want something more on the server side than the client side. Cryptographically bound, I think, is an open question still. Eric?
Yeah, so I don't think, based on the description, I don't think the client side is viable. So I would not. I think we need server side. I think my position on cryptographically bound was clear. I think it'd probably be useful to like actually try to talk a little bit about what threats we're willing to tolerate from the server and which ones we're not, rather than just sort of like then we talk about implementation details, but like the relevant question is what is it we wish that are designed to provide in terms of security against the server. And while I don't have anything like a complete description of that, I think it needs to include the server not being able to like read the messages, the server not being able to falsely inject a user into the group. I do not, however, think it needs to, or at least it's practical at the moment, to conceal the group structure from the server, or to perhaps conceal other things like that. But I do think if you look at it from the perspective I just indicated, that does tell you, for instance, that that the server may or may not be able to modify the configuration, because if the server can modify configuration, then they can basically change that permissions. So if you think that the room has to be cryptographically protected, the membership has to be cryptographically protected, then probably the configuration has to be as well. So so I think, again, like, I think it'd be more useful, rather than discussing the precise details of like how we implement things, to discuss what we're trying to achieve in terms of protection against the server.
Yeah, fair enough. Conrad?
Yeah, I think that's an excellent question in terms of threat model and its lenses. Can you hear me?
I can barely hear you, yes.
Okay. Sorry, I'm trying to fix it. I'll raise my hand again then.
Sure. But yeah, to Eric's point, like, having a lot of this stuff server side, obviously if it can just create events and create configuration, then that is a problem when you want cryptographic proof that that change can happen or has happened, which I think is just basically saying that we do want that cryptographic proof. Tim?
Thanks. So one thing I'd always try to keep in mind, Mimi, is that like the objective here is to get a number of existing systems to gatekeepers to talk to each other. And so I wonder, like, what are actually the existing capabilities of these systems? My understanding is that for a number of the systems that are, that we'd like to see interoperate via Mimi, the server operators can already, say, impersonate arbitrary users because like they control identity. What I'm less confident in is to what extent can, I don't want to pick on any particular vendor here, but like to what extent can existing server operators add members to a group in existing deployed systems?
Yeah.
I bring it up because, like, if Mimi goes and says, designs a thing that makes that impossible, I wonder if that then is like a deal breaker for some gatekeepers.
Yeah, so generally, yeah, like the gatekeepers and existing messaging providers, like you said, do have the ability to just impersonate their own users, for instance, and just do whatever they want as their users. There's obviously a social contract there that, you shouldn't do that. But in the sort of rough case, it's very clear that, if you want to take over a user's account and change the permissions and that sort of stuff, so long as you have the ability to do that, then there's nothing stopping the sort of service provider from doing that. So with the cryptographic proof, that is, I think, an additional requirement that doesn't necessarily translate to the existing gatekeepers.
So, Tim, I wasn't really clear whether you meant there are features like the ability to go and add new users that are in, example gatekeeper A and B, like WhatsApp can do that, right? And does this allow for that? Or was your question, if you allow people to add users to a conversation, what does that do to somebody who can't do that, like iMessage? And I'll just go ahead and hop in and say that I think iMessage is fundamentally broken at its protocol and in its user interface. And so if we try to base Mimi around that, we're going to end up with something that just doesn't work.
Fair enough.
Yeah. Conrad?
Okay, is it better now?
It is different.
Okay. Geez. Okay.
It's understandable, at least.
It's
You're trying to
understandable.
fix it.
Okay, I'll give it a go for this pass, and then I'll try to fix it for the next one. So I just essentially just want to second Eric, and I think it comes back to what we talked about in terms of security requirements rather than functional requirements. It comes back to the discussion we had on metadata last time, to where we have to work out a threat model and figure out which of these security or metadata requirements we want to meet. And I mean, we should do that separately, but I think these discussions on different approaches to running a server at least kind of gets us closer to what we want. So I think it's a good discussion to have for sure.
Eric?
Yeah, so I think Tim's making an important point about not trying to get out too far ahead of the existing systems, which do not have great security properties. But on the other hand, I think my take on what we ought to be doing is try and design a system that was compatible with existing systems, which had, as Tim notes, somewhat inferior security properties, but also could be constructed in a way that has stronger security properties that provides a bridge to a bridge to a better world. And so to take probably the most egregious example, right, the fact that the existing systems basically don't have any kind of mechanism for any impersonation. Well, we do have technical mechanisms that potentially avoid that, in the form of key transparency or something like that. And so what we ought to be designing is something that is compatible with mechanisms that provide impersonation by the server, even if it also can be run in a mode that does not have those mechanisms. Now, I think in that case, it probably requires almost no extra work, but maybe there are things that require some extra work, and then we have to figure out, what those things are, and whether we need to leave extensions for them or actually deal with them, but have opt-outs or whatever. But I think I wouldn't want the system we designed to be like the minimum of all possible known existing systems, but rather to be at least compatible with the best we know how to do, while also supporting the existing systems if necessary.
Yeah, something that particularly like on the matrix side, just to quickly respond to that, that we aim for is maximum compatibility rather than minimum compatibility. Just because, like it's more important to have those sort of aspects rather than cause problems for yourself. Alyssa?
I think Ecker said most of what I was going to say, but I do think it's also just worth considering that the posture of any given service provider towards what they want some other server to be able to do, as they have other users interoperating with their own users, is maybe not necessarily 100% the same as what privileges they reserve for themselves today in their existing services. So I think we can be like a little bit more aggressive about the security properties that we were just talking about because of that. And I was also just noticing that Matthew posted into the chat this gatekeeper comparison that he had promised to deliver, and I think now people can look at it and take some time with it. But I think we should come back around on this in a future interim and on the list as people kind of digest this, because we can also use this to try to synthesize like what the actual superset of the existing gatekeeper functionality is that we think we want to support.
Yeah, a lot of this conversation was started based off the idea of what do we want to achieve as a working group, because it was kind of undefined at the previous interim. And thank you, Matthew, for sharing the document.
Just one other thing, just to throw it out there. I feel like because we're now until whatever the 4th or 5th meeting, and we have this kind of long running thread about like what do we think the requirements should actually be, I'm probably going to start just collecting all the ones that we've talked about thus far and putting them in some document that people can edit and add to, so that we can start to have like a single reference point for what we think we are slowly coalescing around in terms of what these security and authorization metadata requirements are.
Yeah, that would be very, very helpful, particularly from my side of trying to build something that meets the unknown requirements. It does sound like, though, that, yeah, so like we have the rough consensus that something server side, possibly with public MLS messages, is the rough target. I guess cryptographically bound, I guess state in general, not just room membership. That, I guess, is an unknown, depending on whether or not we think it's a useful characteristic. But I'm also mindful that we are out of time on this slot, so I will leave it to the chairs to decide if we can continue.
Well, we have another hour in the session today, and there's nothing else on the agenda. So if there's still stuff to be discussed on this topic, I think we should pursue it.
Fair enough. Eric?
Yeah, I just, and sorry, I missed the beginning, so I don't know how the chairs teed this up, but I think, you know, as I understand it, we have not yet decided on a starting point for this piece of the protocol. And so I think probably the focus of this discussion should be not necessarily answering questions about how a linearized matrix ought to look, but determining whether a linearized matrix is a suitable foundation for the beginning of the working group. Well, I think definitely we should move forward and like hear more. If you have more to talk about, I think we should be focusing on those questions. Because, like, for instance, this question of cryptographic binding is like a great question, but like since matrix doesn't do it and like draft Rosenberg doesn't do it, we have to add anything. And so, like, I think it's probably I think we should focus going forward on like whether a linearized matrix is like a good foundation. Which I'm not saying it's not, or I'm not saying it is. I'm not supposed to have an opinion on that yet, but that's what I'd like to. That's what I'd like to get out of this conversation is be able to form an opinion about whether linearized matrix is a suitable foundation. And I guess I said I don't know how to sheet this up, but if say Jonathan Rosenberg wants to argue that draft Rosenberg is a suitable foundation, then he should be making a presentation like that as well.
Yeah, I mean, like, this is the last slide in the deck, but and I'm obviously biased. I do think it's a suitable base. Yeah, if we want to shift the conversation in that direction, I'm totally okay with that.
I guess what might be helpful would be and obviously I'm not asking you to really argue against interest here, but like, what are the challenges you see, starting from the linearized matrix that we'd have to resolve that like perhaps might not be the case if it's some other protocol, and what do you think, like, I guess the advantages are pretty clear, which is like it's starting from like something we already know that already exists and works. But I guess there are other advantages of this design, as opposed to some of the other designs we've seen floated, what those advantages might be. Beyond the fact that we just know it's based on a tautology we know works.
Yeah, I mean, like that's the fundamental one, is it already exists. Like the draft is extracted from the existing matrix spec, so it already functions in that respect. The other sorts of benefits are like, it honestly just comes down to just it's existed for a while. Like the auth rules have been narrowed down quite a lot, but I guess speaking to disadvantages, it's the stuff that we already kind of talked about, where because it's a server-side model, in Matrix, because Matrix has its own encryption existing already, a lot of these problems are fixed at that level rather than at the sort of transport or superset communications layer. With introducing MLS to the stack, we have the issues where servers could theoretically inject devices, which we obviously don't want. So trying to come up with those rules is sort of greenfield new tech that needs to be decided on, where the existing sort of matrix spec using a not MLS encryption has already solved a lot of these areas. But like we'd be building off of that experience and those characteristics to help shape how MLS would work. I will also just pass it immediately to Matthew and see if there's anything that I might have missed briefly there.
Sorry, couldn't find the tab. No, I think that covers it. Travis, but very happy to try to clarify as needed.
Yeah. I guess have people had a chance to go through the draft at the moment, or is it still, or like it being published 12 hours ago or 24 hours ago, too recent? But Eric,
I certainly have not. I certainly have not gone through the most recent draft. I read a previous draft. So I will have to read the new draft. I guess, do you see there being significant architectural differences between like this design and like Jeff Rosenberg? And if so, what do you think the thought? I guess I'm sure trying to get at is like, I definitely like, I think there's a lot of merit and like this has already been done, like it works, but like, but like obviously, and anything like I guess anything made in anything else. So I'm wondering, if you like look at Jeff Rosenberg, and I guess Jonathan's not here, so like I don't want to like do too deep into it, but like, are there things you would say like, actually, I don't think this is going to work because it's for some architectural reason that linear matrix solves?
From what I've seen of the sort of existing alternative proposals, we'll say, because there are a couple of them, the rough theme seems to be that there are like several minor, some cases more major problems that like they're about to run into that we've already solved. We also mentioned previously just like almost all of them use some sort of UUID or namespace for what we would call event IDs, whereas in Matrix we already ran into that problem, already created a room version to solve it, and started using hashes. That sort of side of things is like, I think where linearized matrix, definitely has some sort of standing. The existing proposals architecturally are all pretty much the same. I think we discussed that at the last interim, where it's all of them have some sort of central server that deals with the fan out for the other servers, and the other servers just kind of send it through that, and on a roughly per conversation or per room basis. Linearized matrix is the same thing. Like it sends it through a hub server. The participant servers kind of exist. Something for the later requirements would be, do we want to be able to move that hub to a different server? Like, let's say provider A just has no interest in running the room anymore, but provider B does have an interest. Is there sort of merit in having that be transferable state of some kind?
And it's worth noting the existing decentralization stuff in Matrix means that moving the hub around could be much easier, because you could use basically a subset of the proof logic that is used for the full fat decentralized matrix in the context of linearized matrix in order to securely hand over a hub from A to B. I think there was also a difference on MTP in terms of mutability of events or messages. That I seem to remember the jury was out on whether the message contents was immutable or not, whereas in Matrix we've gone deep down the immutability rabbit hole, and it's worked out quite well, albeit with things like redactions being, deletions being append-only messages that you put into the log, which then go and preserve the integrity of the previous messages by only deleting the human visible pieces, whilst keeping the hash and thus the ID intact, which is quite a nice property.
Conrad, you're unmuted but not providing audio.
I thought I had a solution, but apparently it doesn't work. Anyway, so to jump in here, so last I looked at the combination between Matrix and MLS. Like, one of the issues was Matrix's functionality of essentially supporting longer-term net splits. So is there how does this relate to the linearized version? So do people have to keep key material around to essentially potentially recover from a net split that they might or might not know about? Is this something that is still present in linearized matrix?
Linearized matrix deals with network partitions differently. So with the existing sort of matrix side of things, or the DAG capable matrix, to just be more clear about it, in there, yeah, you need to have an encryption protocol that understands that some servers might be slow to send their events or might never send their events. So like that creates a situation with an MLS where that just becomes difficult. With linearized matrix, because everything runs through a hub rather than being a full mesh transport, you end up having the situation where basically as long as the hub is online, you should be able to send information between other servers, and it's less important if the participant server doesn't receive things, because the hub can theoretically say, hey, you haven't received anything, you can't produce anything until you receive all this stuff. But equally, if the hub goes down, nobody can chat anywhere because there's nowhere for the conversation to go. So that's an advantage more on the matrix side rather than on the linearized matrix side.
It's also worth noting that even on normal matrix, we're moving away from this idea of keeping key material around in case of a net split, because it's almost an impossible problem to solve. Because if you have a network partition and some devices get added on the far side of the partition, then obviously you're not going to encrypt for them at the time because you don't know that they exist. And so you would have to go and re-encrypt and effectively exfiltrate the information out to them, which has a whole set of obvious trust problems associated with it. So what we're actually switching to, particularly in the very latest generation of matrix clients, is to just disable the key gossiping functionality entirely. So we've got this new client called Element X, which is built on a new Rust SDK. And about 2 months ago, we made the decision to just turn off the key gossiping functionality outright, and instead handle basically a UI feedback mechanism that says, sorry, you can't see this message because the person who sent it didn't know you existed. And empirically, users seem to be able to get comfortable with that if it's presented simply enough, because in the decentralized world of matrix, it's obviously a bit of an edge case if you have a net split, and telling the user, sorry, the network was all over the place and they never sent you the keys, almost feels understandable. But as Travis says, that doesn't even happen in linearized matrix because you don't have the ability to have network partitions in that manner.
Richard?
Travis, can you speak to the state of the art in terms of implementation and any interop testing that may have been done here?
Yeah, so like we've written a linearized matrix example server that I continually forget the name of, which is a bit embarrassing as I wrote most of it.
Eigenserver.
Yeah, Eigenserver. But yeah, so like we've written the example implementation of it, and so far, like it's taken days rather than months to actually make the thing function. The interop side of things, we've proven it can work with Synapse, which is a traditional matrix home server, capable of supporting DAGs and all that fun stuff. So like we do have the interop with obviously our own stack. We're just kind of working out the details of making it function with something that isn't matrix branded, I would say.
Yeah, it seems like the interesting case here would be someone who had who didn't have any matrix heritage, starting from the spec and working up to some level of interop with your code. So it sounds like that hasn't happened yet.
Sorry for playing fast and loose with the queuing discipline, by the way. But we do have 2 different compliance suites that we've already written for Matrix as a whole, admittedly looking at the client-server API as well as the server-server API. There isn't one yet for the new linearized Matrix server-server API, but one's called SciTest, and slightly embarrassingly, is written in Perl 5, and the new one is called Complement, written in Golang, and both of them are published by the Matrix Foundation as a compliance test suite, basically, to exercise the API surface, which basically maps directly onto the MIMI, or at least it's a superset of the requirements for the MIMI use case. So for linearized matrix, going and switching the existing federation tests in complement to instead exercise LM basically means that you get a compliance test framework for free, if I understood your question correctly, Rich.
Ish. I think what would be interesting here is, whether there was, a second implementation that would run against something like that. But like I said, it sounds like so far we've just had the matrix elements implementations, which don't get me wrong, that's good work. But I think the next interesting big step would be to have independent implementations that could do some level of interop.
A really interesting bet could be to take an existing normal matrix server and make it to a linearized matrix potentially. So we have Eigenserver as a complete standalone clean room thing that Travis wrote and then forgot the name of. But taking the existing ones already out there and making them speak the dialect too could be those points. Or we could potentially get one of the independent matrix servers. There's a really nice one in Rust called Conduit, and get the Conduit guy to see if they were up for going and implementing the LM dialect to have a proof point.
Well, I mean, those comments seem pretty focused on going kind of down from regular matrix. I'm also interested in the up version where you start from nothing and you build up to just doing the linearized matrix.
Yeah, I'm aware of a couple implementations that are planned, I would say, that aren't written by us, that are in theory going to be compatible. I would basically just ask that, if people feel so motivated, taking a look at the draft, implementing it as server side, and basically saying like, hey, this isn't going to work, or this will work, or it will work with changes, which is probably the expected state there. Eric?
I wanted to clarify, like to sharpen Richard's point, that the standard here is like that I have to be able to read this document and nothing else. There's not in the IETF format and implement the thing. So like so like definitely a starting point as a matrix server does not like help move that forward. So I think like so I mean I'm not saying it has to be the case now, but that will have to be the case eventually. And so I think that the most interesting question is how hard is it for someone to get to that point?
Yeah, the current draft has no references to spec.matrix.org, unlike the previous draft. So it should be currently self-contained. Just for people who might be interested in implementing it. Richard?
Yeah, I was just skimming the draft, and that's a super positive development. So thanks for that. Just to soften Ecker's point a little bit, obviously that fully independent implementations just from the spec is the standard to which we aspire for the final stuff here. I think the question, as Ecker pointed out earlier, before the working group here, is like, what's the right basis for the MIMI working group to point out to start from? And I think to get to that adoption question, you'd want some level of independence, but you could probably allow some level of coordination, but still kind of working from the spec and without a lot of external tools. So you'd want to start from something where you can get some interop, and then reduce the level of coordination you need, reduce the level of dependence on extreme stuff. So I think yes, we want to get to independent implementations, but to the adoption question, we just need some basic, some more basic demonstrations of that.
Yeah, fair enough. Alyssa?
Yeah, I mean, I think this exercise, it serves multiple purposes, right? So if you had somebody who was starting from zero and trying to build up just based off of the spec, it improves the spec quality because you immediately find out all the things that aren't there that need to be added, and that's like a fine fine thing to do, but also like validates whether this design provides all the functionality that some other third party would be looking for if they're interested in interop. So I think both, having both of those things as benefits is reasonable at this stage, right? I think eventually, like some independent party being able to implement the thing from the spec is a good objective, but that's not where we are today.
Yeah, Matthew?
I remember to press the Q button. So I've been talking to 2 different independent outfits who were interested in independent implementations of linearized matrix, basically as a way to plug it into existing non-chat servers. So Mastodon style things where people don't have encrypted DMs but want to have a sort of simple, easy to implement, don't have to run a great big full fat matrix server way of hopping on board. So I can certainly nudge those guys and see if there is appetite to crank out an implementation. Again, clean room purely from the internet draft without cheating and looking at spec.matrix.org. And I can certainly find folks who can pretend to be independent from within the matrix ecosystem, well, independent development at least, who could have a play with it as well. I think it sounds great. I mean, bring it on. The whole point here is to have something that people can implement independently.
Yeah. Richard?
Sorry, it took a second, but I managed to get the slides on the top of the mute button. So I wanted to like rewind a little bit here. So changing topics in case anyone wants to stay on the current topic. Someone brought up a few minutes ago the client server API. And it reminds me of a question that came up in my mind with regard to linearized matrix. The picture, kind of the architectural picture you showed before, had servers talking to servers. And so I believe LM is based on this matrix server-to-server API. But it seems like the follower servers, the participant servers, as opposed to the hub servers, those servers aren't really doing much as servers. Like all the ultimate decision-making happens up on the hub. So forgive me if this is a naive question, but like, I wonder whether the client server API might actually be a better fit for this sort of simplified use case.
Yeah, Tim, if we can go to slide 4. So this would be the architecture diagram of like how this works. So yeah, linearized matrix is based off of
sorry, just to put a like elaborate this now that we have this in front of us. Like what I'm wondering is like these blue links from the servers up to the hub would be the matrix client server API or whatever simplified definition of it we do here. And the green links out to the clients would be whatever provider A speaks, whatever provider B speaks. And the job of the server would be just to map those operations up into the interoperable thing.
Yeah, I'm slightly concerned, I guess, that like there might be sort of basically terminology overloading going on in a sort of sense, because we did so like the blue lines here between the providers, that is server to server, but there is obviously a client from a network perspective. So linearized matrix is based off of the Federation API. With all that consideration, the matrix client server API is honestly like way too complicated to even really consider for this sort of like for MIMI. We are intentionally leaving it as a like the link between the green and the blue. That is, we're leaving that up to the provider, although there are implied constraints. Like you will need a way to send an event, you will need a way to get key material, that sort of stuff.
Hannah said, Travis, I think Richard's point is why do we even need a separate SS API to CS API is not a subset of the client-server API enough to go and get messages from A to B? And I sympathize with the question because I can literally remember asking it in like 2013 when we first started Matrix and said, hang on, guys, if we're just synchronizing a bunch of events between servers, why do we have a completely different API for synchronizing them from servers to clients, particularly for the subset that is needed here? And I think it's right to have completely different flavors of APIs in the end between the two, because you're optimizing for totally different things. The clients basically need to see a partial view of the total data on the server. And so, for instance, on the Matrix CS API right now, we're on our 4th generation of sync API. And the whole idea is that it lazy loads only the data that the client needs to see onto the client. So you just do not get any information about other rooms that you're not looking at. You don't get most recent messages. It's almost a GraphQL style feeling where you pull in as rapidly as possible the bare minimum to have the most responsive, fastest time to first interactivity app imaginable. And that's how Discord and Telegram and the other really, really performant mainstream apps are doing it. And that's just a fundamentally different problem to how do you synchronize the message backlog on this server through to a hub to a different server. You don't need any of that lazy loading or GraphQL style semantics. It's much more of a message queuing thing.
Yeah, the transport between servers here is like deliberately as simple as it can be, which makes it look very similar to a client-server API. But yeah, the rough idea is that, yeah, you send an event, you receive an event, and that's about it.
Yeah, I guess what I was thinking was sort of that, the providers here, the non-hub providers, servers here, arguably don't need to receive things like changes to the rules, to the authorization state, because they're not going to, they don't need to enforce that. It's all enforced to the hub. So it seemed like they were more in a client sort of posture, but I can see Matthew's arguments. There's, other stylistic differences. For instance, provider B server there is serving multiple users, and so if there were provisions in the CS API that were doing things specific to one user, those wouldn't be appropriate. So, yeah, I can see the argument that there's differences here.
Yeah, there's also just the aspect of at the protocol level, we're not trying to make decisions for the other providers, if that makes sense. So for instance, while provider B might literally just be a straight through proxy, like it's just not actually looking at the payloads, it just assumes provider A there is properly handling things. The clients on provider B might want to know that, a new admin was added or somebody was kicked from the room, like just to visually show it to their users. And so, like, while the information getting sent over the wire might not be important to the server operation, it still might be important for user experience.
Yeah, that makes sense. Thanks.
Yeah, Conrad.
I like the idea, and again, we thought about this as well. And I mean, at least partially, you can have overlap between the client to server and server to server API. I think, right? So in the sending case, the server is really just essentially a dump pipe forwarding the messages, but in the receiving case, obviously the client's server has to do the store and forward stuff, and obviously there you can have a more sophisticated API doing the GraphQL things that Matthew just mentioned. So I mean, we don't have to go all in on this, I guess, but why not? Allowing it partially might also be in the interest of metadata. I mean, my own server might not have to learn with which other servers I'm talking, or well, at least not immediately, I guess, or yeah, those sort of things.
I think it may almost be a semantics question in the even a terminology question in the end, and that what really is the difference between a separate server API and a client server API, other than almost the prefix on the API on the URL itself, because if you have two different ways to send messages, one of them is more message queuey, the other is more actually I'm trying to think of the differences between sending messages. The difference on Matrix is that when you send via client server API, you don't need to understand the DAG or the linked list or whatever the underlying data structure is for the room. You just send a message and you've got a transaction and it's not within the context of anything else. Whereas when the servers synchronize the messages together, it's in the context in linearized matrix of a linearized linked list or a normal matrix as a DAG. And so the permissions which are applied by the server, well, the messages are synchronized in the context of the permissions which are being sent on the server. But what I'm trying to say is that whether you call that one API surface or two separate ones is pretty arbitrary.
You know what?
Yeah. Sorry, like just briefly on that, Matthew. The way that linearized matrix is currently structured as well, provider B doesn't actually need to know anything about the linked list. It's only provider A that needs to know about the history and enough to fill like the previous events, that sort of stuff, because it'll rebroadcast basically the correct or final form of whatever the event is out to the remaining servers. Eric, you were going to say something? Or not?
Yeah, I mean, okay. Yeah, then I guess I'll jump in. Yeah, I mean, that's kind of what I was getting at. So my understanding was that with linearized matrix, the other servers really don't have to know anything, and the whole state is kept on the hub, which is kind of essentially goes to mimics what's happening in MLS, where the most important stuff is actually happening on the client sides, and the server is just tracking the state to assist clients in joining or do some verification stuff. So I guess there's no real like reason not to have clients interacting with the provider directly, if that's what they want.
Yeah, like this would be the I guess benefit of something like MTP or MIMI transport protocol, is it doesn't actually say it's a server-server API or a client-server API. It just is an API, which is, yeah, I think arguably, or like in essence, yes, linearized matrix could be defined or characterized as either. But yeah, like maybe I'll just take it to the draft and call it an API. Matthew, you're still in the queue.
Incompetence.
Okay, so anyone else have things they want to discuss? Tim and I are going to try to summarize and give you some homework. Okay, so so here's my assessment of where we are, and I'll like propose some next steps, and people can react to those. So I feel like we've had some productive discussion, sort of more in the requirements and design decision space about the transport protocol in the last few meetings, and that's been good. I do think that needs to be synthesized and put out to the working group so people can evaluate that and react to it. And so that's something that I will aim to do. I think as far as linearized matrix, there's a couple things. First of all, we got the draft and the update yesterday. So I think the first thing is like people should really sit with this, you know, take a look, see what you think. And if you have additional questions or you think there's, you know, other aspects that we didn't discuss today that you want to discuss, like please send mails to the list and we can have that discussion on the list. I think we also talked about trying to find some independent, non-matrix based parties who might be interested in getting going on interop testing with linearized matrix. And I think that would be a very valuable process for us. And as we go forward on both of those things, both, you know, people looking at the draft and also, you know, potentially getting some interop testing going, it would be good to move towards eventually, and also like comparing against these requirements and the synthesis from the gatekeeper comparison that Matthew shared. Those are kind of the things that we need to do, I think, to get to the step of saying, like, do we want to either adopt linearized matrix as a target for the standard that we're supposed to produce for the transport protocol, or do something else? And we still have MTP as another proposal. So I'd really like to push forward on that over the next like month, let's say. We have an interim in 2 weeks, and we can schedule another one prior to IETF 117. But I think, you know, gathering all of that information together will help us get to the point where we can say, you know, do we want to adopt some protocol and doesn't meet the set of requirements that we think we've mostly agreed to. So the homework would be read the draft. If you're interested in interop, let's get interop testing going. Read the gatekeeper comparison, and if you have reactions to that or thoughts about what is the subset of requirements that we should be aiming to, send those to the list. And I have homework to synthesize requirements in general and send that to the list as well. Thoughts?
Sounds great.
Yeah, only thing I'd add is if there's anything unclear in the existing draft, just please let me know, either over the list or directly. I don't mind either way. I would love to help people get set up on implementing or interop testing.
Okie dokie.
Great. Well, I think that's it. Tim, anything else?
No, I don't think so.
Excellent. Thanks, everyone.
All right, thanks everybody. We'll see you next time.
Bye. Thanks.